Hi, can you let us know a little bit about yourself?
Sure. Hi, I'm Ananya Singh and I'm from India. That's where I pursued my bachelor's in pharmacy, and then I went on to do an Erasmus Mundus joint master's degree in sustainable drug discovery. And currently, I'm a doctoral candidate in the Marie Curie doctoral network called ORGESTRA. That's where I work on developing mRNA based lipid nanoparticles for the treatment of cystinosis.
That sounds impressive. Let's talk about your journey. Tell us what made you want to work in science.
Oh, that's a good question. I think, like most scientists, it was just the curiosity that also drove me. I really loved turning the what ifs into, let's find out. And I think science and my job lets me do it every single day. So it's still curiosity, but this time with a purpose.
And what are you up to today?
Today I'm here to culture human myoblast cell lines in which I will test the lipid nanoparticles and see whether the mRNA can be delivered in these cells.
What do you like the best about your workplace?
I think the best thing is the collaborative energy that we get from here. For example, we are given many opportunities to share our work and to learn from other people's work, which eventually leads up to a lot of quick discussions, which then lead to a lot of collaborations, and I really
That
like
sounds
that.
interesting. Could you tell us more about your project?
Sure. I work for the treatment of cystinosis, which is a rare lysosomal disorder. It is caused by a mutation in the CTNS gene, which encodes for a lysosomal transporter called cystinosin. When this protein is non functional, cysteine accumulates inside the lysosomes and gradually damages the cells. The kidneys are often the most severely affected. To address this, we are developing mRNA based therapeutics. Basically, the mRNA for the CTNS protein is encapsulated in lipid nanoparticles. The idea is that once the mRNA lipid nanoparticles are delivered, cells can transiently produce functional cystinosin, restoring the lysosomal export of cysteine and providing functional rescue.
That sounds amazing. So, what's the most interesting part of your research?
For me, it's how dynamic mRNA therapeutics can be. Unlike traditional gene therapy, they don't permanently alter DNA. They act more like a biological software update. For example, you can control the dose, you can control the timings, and even switch off if needed. It's really precise and it's very adaptable.
What is the impact of your research on society?
Well, if successful, this approach could provide a new treatment for cystinosis and potentially other rare diseases as well. More broadly speaking, it's an exciting shift from just treating symptoms to actually treating the underlying disease.
Great. Okay, so I have one final question. If you were part of an orchestra, what instrument would you be?
In an orchestra, I would be the violin. It's expressive, it's thrilling, and always a bit dramatic.